What lies inside a black hole? This is a question that has puzzled scientists and philosophers for decades. Black holes are among the most mysterious objects in the universe, and we are only beginning to understand their nature. Today, we will journey beyond the event horizon and try to glimpse where the known laws of physics break down. From the outside, a black hole appears as an eternal monster, devouring light and matter. But what we see is only the surface of the mystery hidden within. Scientists call the boundary of no return the event horizon. Once crossed, nothing, neither matter or even light, can ever escape. But what happens if we imagine a spacecraft approaching the event horizon? At that moment, time, for an outside observer, seems to slow down. To the external universe, the ship appears frozen in place. Yet for the traveler, a one-way journey into another realm begins, beyond the event horizon of the singularity at point of infinite density. At this place, the known laws of physics no longer function. Space and time collapse into an unimaginable structure. It is here that the universe's greatest secret is hidden. Some theories suggest that inside a black hole, bridges to other universes may exist. These hypothetical tunnels are known as wormholes. They could connect distant corners of the cosmos, or even lead into entirely new realities. Yet, for now, this remains bold speculation. Physicists use Einstein's general theory of relativity to describe the gravity of black holes. It explains how mass bends space and time. Yet, near the singularity, this theory reaches its limits. Here arises the need for a new framework: quantum gravity. The mechanics of black holes are also linked to quantum effects. For instance, Stephen Hawking proposed that they emit radiation. This process, called Hawking radiation, could slowly evaporate black holes. This means that even the darkest objects in the universe are not eternal. But what would a traveler falling inside actually see? Space would stretch, and their body would undergo what scientists call spaghettification. This effect occurs when different parts of the body are pulled with different strengths. For a human, it would be the final, deadly experience. However, some theories claim that spaghettification must only be an illusion. Perhaps the physics at the event horizon is very different from what we expect. The traveler might not be torn apart, but instead enter a strange flow of space-time. This remains one of the boldest hypotheses to unlock the mysteries of black holes. Scientists create complex simulations. Supercomputers model star collisions and black hole mergers. These calculations help predict the behavior of gravitational waves, and with each new result, even greater mysteries are revealed. In 2015, humanity detected gravitational waves for the very first time. These are ripples in spacetime, created by the collision of black holes. Their discovery confirmed Einstein's predictions, and it gave us a brand new tool to study the invisible universe. Gravitational waves carry information about what happens inside black holes. Each signal is like a message from the most extreme places in the universe. The more we study them, the clearer it becomes. Black holes are not voids, but dynamic objects. They play a crucial role in the evolution of galaxies. Astronomers sometimes compare a black hole to a musical instrument. After a merger, it begins to ring, sending waves into the cosmos. These oscillations are called ring-down modes. They help us understand the structure and properties of black holes. But the main question remains: what is actually inside? Some physicists believe it is a region of pure energy and compressed matter. Others suggest it could be a passage into new dimensions, and all of these ideas still await confirmation. To get closer to the answer, scientists study black holes using next-generation telescopes. For example, the Event Horizon Telescope captured the first ever image of a black hole on astronomers. Look at the image of a black hole's shadow. They are not seeing the hole itself, but its boundary. The bright light around it is created by plasma swirling at unimaginable speeds. This light is bent by gravity. That is why we see a ring, like a fiery halo, a shadow. This was a breakthrough in astronomy. For the first, but beyond this ring lies a region we cannot directly observe. Inside are hidden answers about the nature of space and time. Could matter exist there in a new state? Or does everything collapse into an endless point, the singularity? Time. We saw the edge of the invisible. One hypothesis suggests there could be a quantum remnant inside a kind of core. It might preserve the information of all matter that ever fell into the hole. This idea helps to address the so-called information paradox, but as of now, we have no proof. Other scientists think that inside a black hole, space may connect to another part of the universe. Such a structure would resemble a tunnel, known as a wormhole. In theory, it could allow instant travel across vast distances. But for now, it remains daring speculation. To test such ideas, humanity must advance not only telescopes, but also theory. We must unite quantum mechanics with general relativity. Only then will we have a chance to describe black holes fully, and perhaps uncover the secret of what lies inside. Sometimes scientists say that black holes are nature's laboratories. Within them, the most extreme conditions combine: immense gravity, extreme density, and quantum processes. No experiment on Earth can recreate such a scenario. That's why black holes are the key to new physics. One of the biggest paradoxes is the fate of information. If matter vanishes inside a black hole, does its information disappear too? Stephen Hawking believed that information could be lost forever. Yet modern physicists suggest solutions in which the information is somehow preserved. This debate is known as the information paradox. Solving it is crucial, and not only for astrophysics, but also for understanding the universe itself. If information can truly vanish, it would break the fundamental law of conservation, and that would mean rewriting physics as we know it. One proposed solution is tied to the holographic principle. It suggests that information isn't lost but stored on the surface of the event horizon, as if the entire inner history of the black hole is written like a hologram. This idea opens up incredible possibilities for science. Thus, by studying black holes, we are approaching the very foundation of reality. Perhaps they will help unify all the laws of nature into a single theory. A theory that explains not only what lies inside a black hole, but also how the universe itself is built. And this answer could change our entire worldview. Modern telescopes and gravitational wave detectors are only beginning to unveil the secrets of black holes. Each new observation brings us more data, but with answers come even more questions. It seems black holes are an endless source of mysteries. Some physicists suggest that inside black holes may lie entire universes. In that case, every hole becomes a portal to a new cosmos. We ourselves might live within one such structure without ever knowing it. This idea makes us question the true infinity of existence. These hypotheses may sound like science fiction, but they are what drives science forward. History shows that many bold ideas were once dismissed as madness, yet later they became the foundation of great discoveries. Perhaps the same will happen with theories about black holes. But how can we test what lies beyond the event horizon? We cannot send a spacecraft there. Even the most advanced probes would never return. So the only way to seek the truth is through mathematics, observation, and imagination. Scientific imagination builds bridges between the known and the unknown. Models, hypotheses, and simulations help us inch closer to the answer. Black holes become the arena where new ideas are born, and where, perhaps one day, we may find the key to the entire universe. When we talk about black holes, we often forget they are not abstractions, but real objects. They are born from the death of massive stars. When a star can no longer resist its own weight, it collapses inward, and thus, a gravitational abyss is formed. Every black hole carries the story of its star. It bears the imprint of its mass, spin, and charge at birth. These characteristics can be described by simple parameters, but what lies inside remains the hidden chapter of that story. Scientists say that a black hole has no hair. This means it can be described by just three parameters: mass, spin, and charge. Everything else appears to vanish without a trace. But what if a more complex structure is hidden inside? Some theories propose the idea of a firewall. This would be an energetic barrier at the event horizon. It could destroy anything crossing the boundary. But this hypothesis remains controversial and lacks direct evidence. Other scientists believe there is no wall, and falling into a black hole could be calm, at least until the traveler meets the singularity. There, everything dissolves into the unknown, and that ending remains the greatest mystery. Mathematics suggests that inside the singularity, space and time may switch roles. There is no familiar future or past. Everything collapses into a single point, where our logic no longer applies. For physics, this is a realm of absolute uncertainty. To understand such processes, scientists try to unite general relativity and quantum mechanics. These two theories describe the universe differently, and so far, they do not agree. Yet inside the heart of a black hole, they must work together. That is why studying black holes is a step toward creating a theory of everything. But theory is only part of the answer. We need observations to test these ideas. New telescopes, detectors, and space missions are already being planned. Each step brings us closer to uncovering what lies inside black holes. Imagine the moment when we finally discover the truth. That breakthrough could overturn our understanding of the universe. It could change everything, from physics to philosophy, and perhaps it will open the road to the stars. For now, black holes remain a mystery. We know they exist and feel their influence on the cosmos, but their inner world is hidden behind the veil of the event horizon. And it is this very mystery that makes them the most captivating objects in the universe. Black holes have become a symbol of the limits of human knowledge. They remind us that the universe still holds millions of secrets. Every new discovery only pushes us to explore further, for it is within the unknown that progress is born. For some, black holes represent threat and destruction. For others, they are a source of inspiration and hope. They teach us humility before the power of the cosmos. And at the same time, they call us toward new horizons. Perhaps one day, humanity will approach these objects closer than we can imagine. Future space missions may explore their orbits. We will see black holes not only through telescopes, but up close. That will mark a new step in humanity's journey into the cosmos. But whatever we discover, one thing is already clear. Black holes have forever changed our understanding of the universe. They showed us that space and time are not rigid structures, but a flexible fabric, and that the laws of reality will be far stranger than we ever thought. And perhaps the most important discovery still lies ahead. By peering inside a black hole, we may not only learn how the universe is built, we may also discover who we are and what place we hold in this boundless cosmos. that answer could become humanity's greatest revelation. Today, we are only touching the surface of the mystery. Every telescope, every theory is just a small step in an ocean of the unknown. Black holes remind us that knowledge is never final. It always opens new horizons. Perhaps inside black holes lies the fundamental code of the universe. If we could decode it, we would understand not only the past, but also the future of the cosmos. Such knowledge could transform all of humanity. Yet, for now, it remains hidden behind the veil of darkness. For many researchers, black holes are not only a scientific interest, but also a philosophical challenge. They raise questions about reality, time, and existence. When we study them, we are studying ourselves, and in that lies their greatest value. Yet no matter how dark this journey seems, it is always tied to hope. For where there is mystery, there is also the possibility of discovery. Black holes are gateways behind which new knowledge awaits, and thus, their study is a path to the future. And maybe one day, we will peer beyond the event horizon. We will witness what lies at the very heart of the cosmos. That moment will become the most important in the history of science, and the beginning of a new era for humanity. Black holes are not just the boundaries of science, but a symbol of humanity's endless drive for knowledge. We will never stop asking the question, what lies inside? And perhaps the answer will be found not only in the depths of space, but also within ourselves. For the thirst for discovery is our true strength.